All right, we are going to focus on 8.8 out of our textbook, and it is a lesson on solving radical equations. Also, part of this can have inequalities in it, but we are going to focus on equations. So the first thing I'm going to do is start with a warm-up and go back to some old concepts that we have done several times throughout this year. So it will make the lesson a little longer, but I think it's important to do. So this would be a great time to pause and try these problems on your own, and then come back and see how you did. All right, so I'm going to go ahead and work through them, but remember, we are trying to simplify these without using a calculator, as in no decimals. So you can use a calculator as an aid. You really want to know your perfect squares. Notice we're working with square roots at the beginning here, and so the biggest perfect square that goes into 72 is 36. And a lot of people get fooled because they want to use 9 and 8, but 9 is not the biggest perfect square. So square root of 36, square root of 2, we're using our properties. Square root of AB, same as the square root of A times square root of B, and this would be 6 square roots of 2. And that's it. All right, and the next problem, we have negative 2x and then the square root of 125. The negative 2x is going to hang out. The square root of 125 is going to break down to 25 and 5. So that is the biggest perfect square. 25 times 5 is 125. This leaves me with negative 2x times 5. Keep the square root of 5. And so we clean it up. Negative 10x square root of 5 is my final simplified answer. Okay, now the next one has addition here. All right, so I cannot add unless my roots are the same. Just like I can't add unless I have the same variable with the same exponents, I cannot add unless my roots are the same. So the first thing I'm going to do is I'm going to break this down. The 2 is going to stay. The perfect square in 27 is a 9. I'm going to keep a 3 with the x. I can take the square root of 9, the 3 is left over, and the x is left over. I'd have to have a power of 2 or higher to break this down. So this is going to clean up to be 2 times 3 square root of 3x, which simplifies to 6 square root of 3x. Okay, let's carry this down. This is going to break down to the square root of 4 square root of 3x. Okay, same idea. So again, you might just jump to the next step, but I'm going to show it. It'd be 3 times 2 square root of 3x. That gives me actually another 6 square root of 3x. Now, if this was the square root of 5x and this was the square root of 3x, I couldn't add them. But they're both the same thing, so I have 6 of these and 6 more of them. That means I have 12 square roots of 3x. And there it is. Okay, let's keep going. I have square root of 72, y to the 5th, and so we're going to break this down. Now we already saw the 72, so we know it's going to be 36 and 2. And then this y to the 5th, really you can look at it and break it down and know that you're going to have a y squared out and a y to the first left over. But here's what I'm doing. I'm looking at how many groups of 2 I can form. And so the idea is here's 2, 4, and then my 5th one. When I multiply bases, I add the powers. So again, you don't have to write it out that way, but that's where I got that y squared from, because I have a y left and a y left there. So what do I have? I have 6 square root of 2, I have y squared out, and then I have a square root of y. So to write this properly, you put anything that you took out, anything you could take the root of goes out front, and then put everything back together in one root symbol. We should not have more than one root symbol. Your power should always be smaller than your root, or you could have broken it down more. Okay, now here's where we can get a little confused. If you look at number 5, the only reason that this cancels and leaves me just x plus 2 is because that power of 3 was there, and the power of 3 is the inverse of a cube root. Or we could have looked at it like this, x plus 2 to the 3rd, all to the power of 1/3, because remember, a cube root is the same as the power of 1/3. And power to power multiply leaves us a power of 1. I cannot just come into a problem like number 6 and say, well, I'll square it. And that's something I want to make sure I bring up, because that is what we're going to do when we have equations. I cannot do that with an expression. I cannot come in and just square it and say, hey, I canceled the square root. I have to have an equal sign, and I have to be able to do it to both sides. So with this problem, already had the power there, it cancels, that's it. I didn't have to do any work. This one does not. Now, there's no square root of 2 and there's no square root of 48. So individually, those aren't helping me. So I'm going to go ahead and put it together as a 96y. And then I want to find the biggest perfect square that goes into 96. 4 goes into 96, but it goes in 12 times. I'm sorry, actually it goes in more than 12 times. 4 goes in, and so we can break it down more. So that would be the square root of 16 and the square root of 6. Okay? And keep the y since it can't break down. And the square root of 16 is 4. Keep the square root of 6y. So I always want to find the biggest perfect square and make sure there's nothing else I can break down. Okay, this is a bit of a mess. There's no square root of 11, square root of 2. I can't have a fraction. That means I have the square root of 2 in the denominator, and I'd have to rationalize it. And then I have to break this down and rationalize it. So individually, these aren't helping me. So let's put them together. 11 times 11 is 121. That's amazing because it's a perfect square. And 2 times 18 is 36. So this problem just became a lot easier because the square root of 121 over the square root of 36 is simply 11 over 6. And then double check if you can reduce your fraction, and I'm done. If I would not have put these together, that would have been a lot of work. Okay? Now over here, I can't. The 25 and 3 don't reduce. That's the first thing I always look for is can I reduce? The next thing I'm looking to see is, 25 is a perfect square, 3 is not. So square root of 25 over square root of 3, if you want to show that, I get 5 square roots of 3. You can't leave that because it's not rationalized in the denominator. So we need to multiply it by the square root of 3, top and bottom. So multiplying by 1, and the top is 5 square roots of 3, and the bottom is just 3. Again, that comes from the square root of 9, which becomes 3. Last thing to double check, anything I can break down, anything I can reduce, and that is as simple as it gets. All right, so again, these were all prior knowledge problems, and we're continuing with the review. This comes from our content from 8.6 with radical expressions. And so it just says write each in radical form. I'm not doing anything else. So x plus 6, all in parentheses power 1/2, is the same as the square root of x plus 6. I don't have to use parentheses, but I would like to, just in case I need them, because there's a 1 here. Now, in this problem, I have 3y plus 4 to the 3/5. This would be the 5th root of 3y plus 4. I have to use parentheses here for the power of 3 because that power of 3 is on everything. All right? All right, so let's dig into our new concepts. That was a full page of review. I just noticed the numbering is off on that, but that is okay. All right, so we can already solve equations by performing the same operations on both sides to isolate the variable. So just using our order of operations backwards and isolating the variable. We can use the same concept to solve radical equations. So a radical equation is simply an equation that has a radical in it or a root in it. Okay? It contains a variable within the radical, and we're solving it. We have an equal sign. That's what's different. Recall you can solve quadratic equations by taking the square root of both sides. Similarly, we are going to solve radical equations by raising each side to a power. Okay, so we have a pretty basic equation here to walk through the steps. So I have the cube root of x minus 2 equals 0. Now notice the minus 2 is not part of the root. The first thing I'm going to do is I'm going to add 2 to the other side. And when I'm doing that in general, I am isolating the root. So isolate the radical or the root. All right, so I'm getting that by itself. And then the next thing I'm going to do is I'm going to say, well, what gets rid of a cube root? Well, I'd put it to the power of 3. And if I raise this side to the power of 3, I raise this side. Now, this is different. When I am rationalizing a denominator, like this problem here, I'd multiplied the bottom by the square root of 3. I really did square it, but I had to multiply it by itself so I could do the same to the top. Notice I have no equal sign here. So I can't just square it. I actually have to multiply it by 1, and that's what I want you to remember. There's no equal sign here, so I'm multiplying by the identity property, the multiplicative identity multiplied by 1. But because I have an equal sign here, if I raise one side to the power of 3, I can raise the other side to the power of 3. So that's my idea. I'm going to raise both sides of the equation. I'm going to abbreviate equation to the power equal to the index of the radical. So if I have a fourth root, I'd raise both sides to the fourth. I have a square root, I'd raise both sides to the power of 2. All right, then you simplify and solve. Now, this was a pretty simple example. And the reason I say it's a simple example, there wasn't anything else. Once I cubed both sides, this cancels out. I'm left with x equals 8. So we have some problems to try, and there might be some extra steps in there. All right, so here we go. We're finally getting to the lesson. The first thing I want to do is I want to isolate the root. So see that 2 there? I absolutely could jump in and square the whole thing. A lot of people forget to square it. So I'm going to go ahead and get rid of it first. And that's going to cancel out, and I have the square root of x plus 1 is equal to 7. Now, if this doesn't divide nicely, I would reduce it, but I want to keep a fraction, not a mixed number, a fraction, improper or proper. Okay, now I've got this isolated, so I can't get rid of the 1 until I get rid of the root. So I want you to think about your order of operations. Please excuse my dear Aunt Sally. Remember, we're going backwards. We got rid of addition, subtraction first. There was nothing here, and I want you to remember, whatever is underneath the root sign is truly in parentheses. It's grouped in there. So I got rid of multiplication, division. I got rid of the multiplication by dividing it. Next are the exponents. So how do I get rid of this root? Because remember, a square root is part of the world of exponents. So to get rid of it, I'm going to square it. And if I square this side, I square the other side. So this cancels out and leaves me the full x plus 1, and it's equal to 49. So I simplified, and now I'm going to solve. And so x is 48. How do I check that? I would take my 48 and I'd plug it back in. Now we can do some mental math, and I think that's great. Probably take me less time to do that than this. But to show you to put it in the calculator right, it's going to be 2 times, and then I want my square root. Notice the parentheses are here. If you have a calculator that doesn't put parentheses, it might extend your root sign, so be careful with that. And then I want to put in 48 plus 1, and I want to close parentheses. And there's my answer, 14. Okay, so we want to double check that, and I'm only getting one answer. I'm not asking you what squared gives me 7. I'm asking you, you know, once I do this, I'm squaring it, getting 49. I'm not taking the square root to solve. Okay, over here, very similar idea. First, I'm looking for addition, subtraction, and the only thing that I have is in parentheses, so I can't get to it. The other thing I'm going to do is divide both sides by 7. So I still have, notice it's the cube root, don't lose that, of 5x minus 7, and that is equal to a nice 12. So that divided nicely. All right, so once I've got that done, I need to get rid of the root. I've isolated the root, so I'm going to come in and square it, and I end up, not square it, I'm coming in and cubing it. Hopefully you caught that. And this is going to cancel and leave me 5x minus 7, and I'd have to take 12 to the third, okay, in a calculator, and that gives me 1,728. I'm just going to have to deal with it, and then I'm going to solve. So I'm going back to basics. I'm going to add 7. It's a linear equation, and I get 5x equals 1,735, and I'm glad I'm going to get a nice even number when I divide by 5, and I get x equals 347. Okay, even as in, sorry, I get an integer. I get an odd integer. And that is my answer. Again, I would take that and plug it in. Make sure you close parentheses. And remember, I want the cube root to put in my calculator. Okay, now, what's different? Look at example 2. Notice there's a root on both sides. All right? Over here, I had to isolate the root. But when there's a root on both sides, I can't isolate it because it's there. I want to go back to this. Raising each side of an equation to an even power may introduce extraneous solutions. So that's why you want to check your answers. Okay? When I do this, I can actually get a false answer that when I put it back in, it won't work. Remember, I can't take the square root of a negative. So I can get a negative answer, but if I put it in, it might not work. Now this is a cube root, so I can take the cube root of a negative. So be really careful with some of these ideas. Okay? Or if this was equal to a negative number, when I solve it, it seems like it works out. but I can't take the square root and get out a negative number in the end. So be careful, always check your answers because we will get some, and I'll show you some that don't always work. Okay, there is no way to isolate and get the root by itself, okay? So I actually want to leave it on both sides. If I had a problem, let me grab a little post-it note here. If I had this problem and I had it written like this, 35x minus 5 and then the square root of x plus 2 equals 0, because this does come up in some of our exercises. If I have this and I try, we don't want to do this, that's why I'm writing an extra paper, and I say, okay, I got the roots isolated, they're on the left side, and I come in and I square this and I square this. Guys, I cannot square over addition and subtraction. I can't just square that, and call it a day. I have to FOIL this. Do you want to FOIL this? Because I don't. I'd have to take this times itself. So I don't want to do that and do all that time to FOIL it. So I actually want, if this is like this, I don't want to come in here. I actually want to bring this over by adding it and come up with this problem right here. Okay, so a little bit different. So you have to remember that rule. But it's actually not bad. So how do I get rid of the root? I square it. And when I go to square this, I have to square the whole side. And that's one of the mistakes people make. So this is easy. I just get 35x. And I don't think this is bad either, but I have to square the 5. And that's what people forget. That's going to give me a 25. And then the square and square root cancel. And I'm left with x plus 2. And that's another issue. A lot of people would write 25x plus 2, and they would never put the parentheses here. So 2 problems, we forget about the 5, and we don't use parentheses, and I need the parentheses because this has to distribute. Okay, so I have 35x equals 25x plus 50. So big mistake is not distributing that 25, and you have to wait till after you get rid of the root. Now that I have that, I'm going to go ahead and subtract 25x since it's a linear equation, and I get 10x equals 50. Divide both sides by 10, and there you have it. X is 5. Again, I'm going to take this answer, I'm going to plug it into both sides of the original. Make sure you use parentheses. All right, we have another example here. Now, I only have the root on one side and it's isolated, but I have more than one term over here, and that's what's different. So when I go to do this, I'm still going to square this side and I'm going to square that side. The issue that we need to remember is what I just talked about or a little bit ago. I can't distribute a square over addition and subtraction. So over here, that's the easy side. Negative 3x plus 33 equals, and then I have to take this and multiply by itself. Okay, so be really careful with this. So same rules that we did up here. First we isolated and then we squared both sides, but I just had to square a number. Here I'm squaring a binomial, so I have to take it times itself and FOIL it. So I have a negative 3x plus 33, and then take your time and FOIL that, and it's going to be a little out of order, and that's okay. So I'm going to have a 25, a negative 5, and a negative 5x is negative 10x, and negative times negative is going to be positive x squared. So be really careful with those numbers. And then the next thing I'm going to notice is that I have a quadratic, okay? And you can see that reminder down there about FOILing. But I have a quadratic, so I can't get x by itself and solve. I have x squared and x, so I'm going to set it equal to 0 and try to factor, okay? So first thing is, I have a positive x squared here, so I'm going to leave that there, and I'm going to put a 0 here, and I have positive x squared, and then I'm going to add 3x to both sides, which is minus 7x, and then I'm going to subtract 33, and notice I'm pairing up my like terms, so this is old news, and I get a negative 8. Okay, so first I think I'm going to just try to factor it, and that would be 0 equals, and I would have x minus 8 and x plus 1. So double check your factoring, and if we've got that set, then we have x equals 8 or x equals negative 1. Okay, if it didn't factor, I could use my quadratic formula. I could solve by finding the x-intercepts on a graph, completing the square. So there's multiple ways, but the easiest way, I think, is to use factoring and zero product property. Now, if I walk away from this problem, I'm going to get it wrong. I need to take my answers and I need to check them. So if I take 8 and I put it in there, that'd be the square root of negative 3 times 8 plus 33. And then I would get equals 5 minus 8. Okay, so it looks good over here. This would be negative 32. Negative 24 plus 33. Okay. And so I get a positive 9. And then that equals, and I have 5 minus, that's a minus 8, which is negative 3. Now, a lot of you are thinking, well, take the square root of 9, I get 3, I'm good. I don't, I'm not good. I get 3 equals negative 3. So when I say what's the square root of 9, I'm not asking you what squared equals 9, positive or negative. The square root of 9 is 3. I can't take the square root and get out a negative. So this is not true, so I actually have to throw that out. Now, I need to come back, I need to check out negative 1. So take your negative 1 and plug it in. Negative 3 times negative 1 plus 33. Does that equal 5 minus a negative 1? Okay, well that is 3 and 33, so I get the square root of 36 equals, this ends up being a positive 6, so 6 equals 6, perfect. So I have one answer that works and one that doesn't work. Why doesn't this answer work? Well, the first thing we did was we squared both sides and we threw out the square root. So we get this extraneous or false answer. It works here, but if I go back to the original, it does not work with that root. All right, a couple more to keep practicing here. We're looking at something a little bit different. So it says to remember when we can use our similar methods. We remember about using FOIL. We can use similar methods to solve equations containing rational exponents. Raise both sides of the equation to the reciprocal of the exponent. Okay, so we're using rational exponents. Basically, we're using fractions. Okay, that's our rational exponent. But remember, 1/5 is the same as a 5th root. And what would cancel out a 5th root would be a power of 5. Well, the reciprocal of 1/5 is also a power of 5. So something we've talked about. You can also write it as in radical form and then just solve as you were. So let's just talk about this real quick. If I came in here and I have a power of 1/5, I'm going to take this to the power of 5. And if I do it to one side, I go to the other side. And why? Well, a power to power is the rule, right? A to the m to the n is a to the m times n. So I multiply. So this cancels out to 1. A 5th of 5 is 1. And I am left with 3x minus 1 equals 32. And then I can simply solve it by adding 1. 3x equals 33. And x equals 11. You're going to take that 11 and plug it in. That'd be 33 minus 1 is 32. And 32 to the 1/5, and make sure when you put it in the calculator, if you're testing it, 32 to the power, if I do 1 fraction 5, I'm good. But if I take 32 to the 1 divided by 5, it's only going to take it to the power of 1 and then divide by 5. I don't want that. I need to put this in parentheses. Whoops. Let's just clear it. 32 to the 1 divided by 5 in parentheses. And I get out 2. Okay. So, good with that. Now, just real quickly, if I wanted to, instead of saying this to the power 1/5, I could look at this as the 5th root of 3x minus 1 is equal to 2. Same idea, come in, take both sides to the power of 5, and that's why it works out. Okay, so coming back over here, I have a power of 1/2, which is the same as a square root. Now, notice again that this is isolated. There's no number out front, there's no addition, subtraction outside. Same here. So just like we isolated the root, we're going to isolate what the power is on. And then I'm going to take this to the power of 2 and this to the power of 2. So we're really doing the same thing, but instead of being in radical form, we're doing it in rational exponent form. Now, this is not 2x squared, this is 4x squared. I can distribute that power over multiplication. Over here, this cancels and leaves me 4x plus 8. Okay, what I'm noticing is that I have a square. So I'm going to have to set this equal to 0. 4x squared minus 4x minus 8 equals 0. And then I'm going to factor it. Now, before I make my factoring harder, isn't there a GCF? So take out the 4. What's left is x squared minus x minus 2 equals 0. Keep my 4. X minus 2, x plus 1 equals 0. Okay, 4 is going to be 4. X could be 2, or x could be negative 1. All right, now I have to check my answers and see that they both work. So I'm going to come back up, and I'm going to have 2 times 2 is 4. And then over here I have, that would be 8 plus 8 is 16 to the power of 1/2. Absolutely, 4 equals 4, check. Now if I come over here and I put my negative 1 in, I have 2 times negative 1, okay, that's negative 2. And that equals 4 times negative 1 plus 8, all to the power of 1/2. Okay, so that's 4 plus 8, or sorry, negative 4 plus 8, which is 4 to the 1/2, and here's my issue. 4 to the 1/2 is just 2, and so it's not going to work. So that answer is thrown out, and this is my leftover. I'm going to put that negative sign back in there. Okay, so be careful, we have to throw one of those answers out. So I have one answer. Okay, if we keep going here, these are called challenge problems, but I don't think they're going to challenge you. One of the issues here is I have this in the denominator. There's lots of ways you can do this. You can jump in and rationalize it, multiply top and bottom by the square root of x. You could put this over 1 and you could cross multiply. The other way to do it is to jump in and square and square. Okay, so this square cancels and leaves me x, and this would give me 81 on top over x on the bottom. Now the issue is I still have x in the denominator, so I'm really going to multiply both sides by x. Or again, I could cross multiply, but that gets the x out of there. And so either way, whether I cross multiplied or I multiplied out, I get x squared equals 81. And so I want to make sure that I see that this is a quadratic. Now, I have 2 ways of solving this. One, take the square root of both sides, and remember that then x equals plus or minus 9, right? 9 squared, negative 9 squared. The other way would be set it equal to 0, and it's a difference of squares, so x plus 9, x minus 9 equals 0, and that's where x equals positive or negative 9. Okay, so that's what I see. I should have 2 answers, because whenever I take a square, I get plus or minus, or I factored it. But when I go to take 9 and plug it in, that's good. Square root of 9 is equal to 9 over square root of 9. Okay, so 3 is equal to 3, right? 9 divided by 3 works. But if I put negative 9 in, I'm already stuck. I can't take the square root of negative 9 without an I, so this answer is not going to work. It's not giving me a real answer, and so x is only equal to positive 9. It's a domain restriction for the original problem. All right, so again, we've already talked about this. I don't really think it's a challenge. We've already done one like this, but if I square this side, it's isolated, and I square this side, the big mistake we make is that we try to just square it, but you have to FOIL it. So over here, this cancels. I'm left with x squared minus 64, and that equals x minus 4 times x minus 4. One of the other common mistakes I see a lot of is you see the square root, and so kids are like, oh, well, that's just x and that's 8. I cannot take the square root of addition and subtraction. It'd be different if it was 64x squared, but I cannot do that. So I have to cancel it out by squaring it both sides. So x squared minus 64, go ahead and FOIL your perfect square, x squared minus 8x plus 16. All right, and then we are going to set it equal to 0 and solve. Now wait a minute, when I go to set it equal 0, I went to move this x squared over, Oh, and the x squared cancel. So I actually don't want to set it equal to 0. I'm going to just solve for x. Originally I saw the quadratic and I thought I had to factor. So I'm going to go ahead and subtract 16, and that gives me negative 80 equals negative 8x. Divide both sides by negative 8, and so I get x equals positive 10. Take your 10 and plug it in. So that would be the square root of 100 minus 64 is equal to 10 minus 4. Okay, well that's the square root of 36 equals 6. Perfect. Signs work out. That is my answer. Okay, well, this is the last section for us in Chapter 8, solving radical equations. Remember, we did not work with inequalities, but the same rules would apply with inequalities. And the other thing I want to remind you is the only reason I can cancel out that root with the power of 2 is because there's an equal sign there. If I gave you this square root, you're stuck with it. Or you'd have to try, if it was multiplication, break it down. But because there's an equal sign, we can cancel out the root by squaring it. So please don't get this confused with other lessons. I have an equal sign here.